Example 2. Solve each. Round to 2 decimal places and theta is in between 0 inclusive to 2 pi non-inclusive. Then use the calculator to check your solutions. So what this means is when it says round, that means we are able to use your calculator. For letter A, there are actually 2 different ways you can go about that. Now letter B, there's only right now one way for us. So letter A says cosine of theta equals 0.2. That's a positive ratio. And so positive cosine, it's a regular function. There's no inverse here, so mind you. And so that means cosine regular, it's positive in quad 1 and quad 4, since we have to go a full revolution. A full revolution means you start at 0 and then you end back at 0. So we're going to compose both sides by cosine inverse. That will lead us to 0.2. I'm going to find my decimals and type that in. So give me 1 nanosecond here, decimals. As we are loading, I'm going to find my function. Let me double check to see if in radians. Okay, I am. So cosine inverse of 0.2. That gave us 1.37. So let's go back to the notes, type in theta equals 1.37. But that's not all, because we know that we need another answering quad number 4. So here's a reference of 1.37. That means this reference on the bottom is also 1.37. But we're not going clockwise, okay? Because clockwise will indicate we are getting a negative radians of 1.37. But your restriction said it's a positive angle only. So we are going to go from here all the way to here. So what that means is we are going to take 2 pi, which is a full revolution, less the 1.37 radians. So let's go take my decimals again and do 2. Let's see if I can find the pi. 2 pi minus 1.37. That's going to give us 4.91. So go back, record that, 4.91. So you guys have 2 angles in radians. Theta is 1.37, comma, 4.91. Box that up. Now, earlier I said you have 2 different ways of finding the solution I meant for example 2a. Another way is we can graph this out. Okay. To graph this out, let's go back and look at the equation quickly again. As you can see, you have cosine of theta equals to a constant value, and it doesn't have to be constant. So we're going to break this up into 2 equations. The first equation is going to be cosine of theta, which is in decimals. I think you can use x. And the second equation is going to be y equals 0.2 and where they intersect. Remember, back in the days, to find an answer is to find where the 2 functions intersect. So y equals function cosine of a variable, which is that one. And I'm going to change it to from 0 to 2 pi soon. Then next, we're going to do it again. Y equals 0.2. Now over here, I'm going to take the wrench and my x-axis, I want to change that. Let me just move my computer back here. We want it from 0 to 2 pi. So this goes from 0 to 2 pi. Okay, and there you go. And we can even see that we can even label each step as a pi over 2 or pi over 4. Let's do a pi over 2. There you go. That will allow us to see a little bit here where they intersect. As you can see, they intersect at 2 places, which I will be able to spot out here. The first one, let me make it a little bit darker. Projector mode, there you go. So that allows me to see the first point of intersection, which is this dot. Okay, so that's going to be 1.37, which we knew at the height of 2. Then the second intersection is all the way over here past 3 pi over 2. Hopefully, okay, so make sure the y value is 0.2. There you go. So 4.914, which by 2 decimal places is 4.9. Well, make sure my height again is back at 0.2. There you go, 4.91. So as you can see, we get the same exact 2 solutions by graphing. Now example B. Example B, you cannot just go and use a calculator and do like this step right here on example A, like example A. So we actually have to graph it out. So similarly to graphing example 2A, we're going to do the first y equals, you pick a side, okay? It doesn't really matter what the first y is. Whatever side you pick, that's okay. And the second y is going to be 4. Now, some of you said, well, can I move the x to the other side and just do the first y equals to b, cosine of x? Sure. And then the second y equals 4 minus x. Yeah, either one is totally fine. So you don't have to worry about how you write in y equals, as long as one side of the equation, it's on one of the y's, and then this, or on one of the equation box, and then the second on the other side is the second equation. So let's go and do the 2. Okay, so y equals 3 cosine of x plus x. I'm going to delete what we had earlier, so I don't need to worry about extra graphs. So y equals function cosine of x, make sure I close that and go outside, minus, oh, I don't need a function, minus x. Yes, you don't see anything right now because it's hidden below me. And then as you can see, oh, 3 cosine of x plus x. I lied. 3 cosine. What? 3. Okay. And then the second equation is y equals 4. So y equals 4. Y equals 4. Let's find the graphs and see where they intersect. Remember earlier we already restricted it from 0 to 2 pi. Okay, so here's what I got going on here. Let's look back again. So 3 cosine of x plus x is one equation. Let's double check, and y equals 4. I want to make sure I enter those in correctly. Go back out. Okay, oh, plus x, duh, look at that. So I did a minus and they don't seem to intersect. Let's see if that's, okay, so now I entered the equations incorrectly. Oh, wonderful. So from 0 to 2 pi, remember that's a restriction. There's only one location that they intersect. So that's going to be 4.53. Let's go back, fill that in. So theta equals 4.53. Now what happens if I enter this in right here? Do you think we're going to get the same answer? Let's try it out, right? So y equals 3 cosine of x, and the second y, I'm going to do 4 minus x. So the first one, I'm going to delete the plus x. And then we said, okay, well, move the x here, no big deal. Okay, now let's look at it again to see where they intersect. The graphs are slightly different, and that's supposed to be because we modified the equation, but the answer should be the same still. Okay, so let's see this x location. 4.53, look at that. The y values are different, right? And it doesn't really matter. We're solving for the input, which is your x. So it doesn't matter how you move your equation, you should always get the same answer.